few announcements. For those of you that are new, this is our website, our social media, and our LinkedIn's. You can find all of our happenings, events on our website and our platforms. We do our technical meetings third Tuesdays online, and our mixers and tours about 2 to 3 per quarter. Locations will vary. Just to keep an eye on our emails, our posts, and you'll see what's going on. Just start with a few committee updates. Communications. Ruby, were you on the call?
Hi, Ben, I'm here.
Oh, Ronit. Oh, hey, yes. I was looking for Ruby, but maybe she can't chip in at the moment. So the communications committee, of course, is keeping our website up to date, is doing a great job on social media, pushing out all of our events and awards and things that's going on, and sending out our monthly newsletters. If you're not receiving any of our communications, just reach out to us and we'll make sure you're added to the list. Finance committee, Tim, do you want to jump in and say anything about finance? I know White just had a mixer and they were selling some t-shirts, and Tim was instrumental in getting that money collected and sent over to the chapter. We're doing a nice job over at finance, so thanks Tim and that committee. Membership, Russell, you want to take membership?
I could definitely talk about it. We've so membership is just propping its feet up to close out the year. Figure that most of our members have some good stuff going on with their families and their offices and stuff, so we don't want to clog up the calendar too much. But looking forward to some really great site tours for next year. Probably going to see the Carpenters Union Training Hall. We're anticipating some coordination with that, and I think I don't want to put them on the spot, but I think the College of Southern Nevada might show off some of the cool stuff that they do to keep their employees and students safe as well. So we've got some great sites. We're just going to nail them down for first and second quarter of next year. And then we're going to give another go at our virtual happy hour and trivia contest in January. And that should be a blast too. We've got some prizes lined up. It'll be a really good time. That committee, if anyone ever wants to jump in, it's the fun committee. It really is. It's usually the Wednesday immediately following the chapter meeting. It's not meeting this month, but if it was meeting this month, it would be next week, or I mean tomorrow. So just keep that in mind. It's a really fun committee. It meets at 2 p.m. on the Wednesday after the chapter meeting, and it meets virtually just for an hour, in and out. We respect your time, but we have a good time.
Thanks, Russell. I'll keep you on the mic because I know as past president, you were chair of the nominations and elections committee.
All right. So if you're new to the chapter, I was doing Ben's job before he started doing an excellent job at chapter president. So as immediate past president, our bylaws set me as the chair of our nominations elections committee. The chapter year runs from July 1st to June 30th. But we have to vote on our ballot of officers in the spring. And because this is all volunteer, we allow plenty of time to get that slate of chapter candidates together. So the positions that we vote on are president, vice president, treasurer, secretary, and 3 members at large. Some of those titles are pretty clear about what they do, but members at large are a fun position that kind of is like a project-based role, but they're voting members of our chapter executive committee as well. So if you have any interest in those board positions, talk to me, because we'd like to, I can help you understand a little bit more about what's involved in them. And then we can get you on our ballot for the spring election. The other thing that I can use help with, that I have to have help with, is maybe you're not interested in a chapter officer role, but we do have to have multiple people on our nominations and elections committee. It can't just be me. I'm here to make the announcement to kick off the effort, but our bylaws prohibit me from managing this all myself. Thank goodness. So if you want a time-bound service opportunity to contribute to our chapter, if you feel like our chapter gives you something, this is a cool way to give back that's not going to dominate your schedule. Consider serving with me on the nominations and elections committee. So I'll put my info in the chat box, and I'd love to hear from you, whether you're interested in a board position or serving on the committee. And if none of those work, you should at least look at one of our other functional committees like membership or communications. Thanks, Ben.
Yeah, thanks, Russell. It does seem kind of early to start talking about next year's nominations and election slate, but I mean, we're already at Thanksgiving in 2 days, and we know how fast time seems to fly by. So it's good to get a head start on this and make sure we're following all the bylaws and everything. I know you try to say membership is the most fun committee, but I have to say programs is pretty fun too. I know Todd and Reed are both on the call. If either one of you want to jump in, let's give a little update from programs.
Huh.
Sure.
Reed.
So we've got some speakers figured out for half of next year. So we're ahead of things. Things are looking really good. We're getting our CEU packets turned in and stuff. So yeah, we're ahead of the game and good things are happening.
Yeah, thanks, Reed. This committee is doing a fantastic job for all of you. Not only do we present really informational meetings each month, but they put in the work during the meeting, make it working meetings instead of even more time on the side to go through the application process and get these submitted so everyone attending these meetings could claim CEU points if they'd like. So interesting topics, always usually tied to a standard, and CEUs, just keep up the good work. Appreciate what you guys are doing. Right, Suzanne, I know you gave us a little sneak preview of what's happening, but do you want to take the mic with right now?
Okay, well, like I said, January, we're going to have the virtual with Phoenix Wise, and I'm trying confused here because I'm not looking in front of my calendar. And then the following one is going to be Alexandra with Fasteners. She's going to speak because it's Women's Month for March, and then May we're going to have a gathering, another mixer at one of our ASSP members at their residence, and then I don't know what we're doing after that, so we'll figure it out. But we're just trying to get more ideas. Collaborating on each other, getting to know each other, and so far it's going to be a great group of people, women and men, and I'm hoping that we move forward and grow larger in the future.
Yeah, looking at this photo, it definitely looks like you're having a great time as a committee and putting in good work. And if anyone's not aware, Suzanne have designed some amazing shirts. They're on sale for $25. The money goes back to Wise, and that's a great way to show your pride in the chapter and Wise. And they look really cool. They're Vegas themed. So reach out to me or Suzanne if you'd like to purchase one.
And I will order other ones if we need to get, if men would like to get a t-shirt, I'll get men's sizes. Right now I have women's sizes, but I've had a request for a medium and small. So in the near future, probably January, I'm assuming I'm going to order a couple extras just so, because they don't want to purchase any until they get their sizes, which I understand.
Yep. All right, and I'd like to say congratulations to our own membership chair, Lisa Buck, who just got her master's in occupational safety. Really proud of the work that she does, both professionally and personally. She's a great asset to our chapter, and thanks, Lisa, for everything that you do.
Thank you. That's so nice. I'm glad
I
to
wasn't
be
even
done.
expecting you on the call. I'm glad you can make it.
Yeah, thank you. Sorry, I normally have a staff meeting at this time, so it was canceled. So lucky me, I get to attend. Yay, thank you. Thanks for the call out.
Congratulations again.
Thanks.
Yeah. All right, well, we'll move on to our chapter meeting. Today's meeting sponsor is Dominion Environmental. I just want to say thank you to Dominion for sponsoring and being a supporter of our chapter. Dominion's environmental and industrial hygiene consulting firm, providing third-party services. I'm really grateful that Dominion supports me in this role and allows me to volunteer my time for ASSP. It's been very rewarding. Just working behind the scenes, working on committees, on the board, networking. It's definitely been great. By trade, a certified industrial hygienist, but we don't have a industrial hygiene group out here. I know in the past we've done some side-by-side stuff with ASSP, but as far as standalone, there's nothing out here. And so I was able to find a home with ASSP and have been welcomed. And I just really want to thank ASSP and all of you that, that make this fun and grow this community in Southern Nevada. So without further ado, I'm going to have Russell introduce our speaker today.
Took me a second. Sorry about that. So we're really excited to have Philip Rauscher on the call. If you guys were here as everyone was gathering, this is not your stereotypical quiet IH person. I think we'll have a really good time. So Philip's mission in his work is to build better, safer work environments, and he comes at that from an IH angle. He currently serves with the ACGIH as the interim director. He works with the volunteers and staff there. He coordinates their committees. He makes sure that they're delivering high quality education offerings, both digital and in person. And then they also have a publication division with both electronic and print. So a lot of support, he gives a lot of support to their profession. Before arriving at ACGIH, Philip earned his MPH in Environmental and Occupational Health from the University of Toledo. And in his early days in the field, he was the recipient of the 2019 Bloomfield Award from ACGIH, and that's presented to a young industrial hygienist who pursues the problem of occupational health hazards primarily in field work, I guess, as opposed to like a research-based approach. So he's out there getting his hands dirty, moving IH forward, and we really appreciate what he's doing in the field. He maintains his CIH and CSP certifications, and today's topic is going to be a blast. Looking forward to it. Thanks so much for joining us this morning, Philip.
Yeah, for sure. Thank you, guys. So I get to, since I have the microphone, I get to say congrats to Lisa again. So before I had gray hair, I worked with Lisa, and she was always one of my favorite safety managers to go visit. So congrats. And if this is horrible, it's all her fault, and you get to throw things at her, and I'll hide in Ohio, right? That's how this is going to go.
We're glad to have you.
So let me get you on my parking lot screen 3 there. Can you guys see it okay now? Beautiful.
Good to go.
All right. So yeah, I used to work for a living. I kind of transitioned after grad school. I worked at Clearwater Paper, did health and safety there, lived down in Arkansas. It was not a dry heat, and I am not made for not a dry heat. So being from Northern Ohio, I retreated back to Northern Ohio to kind of focus on more on industrial hygiene, right? I became a field consultant. And the fun thing I loved paper. I still kind of miss that industry. But going over to IH was really my passion, right? So one of the things that I always ran into and just over and over again out there in the field was people who are terrified of ventilation, right? Because it's this big thing that's like built into the walls and flows through them and just disappears into this random black box of cleanliness, and then like air is ejected on the other side. And like a lot of people, I treated it like it was some kind of voodoo, right? And it's, listen, if they let me do it, I promise you it's not like a horrible thing to think about. It just takes, a little bit of time, effort to take a gander at it, really just while you're walking around the facility, right? The way I always say it to somebody is, if you ever drank chocolate milk from a straw when you were a kid, like, congratulations, you're a fluid dynamics expert. And that's all this is, right? All we're doing is sucking up air at one point and moving it someplace else, just like you do through a straw, right? But there are some common things that go wrong with it. And frankly, a lot of times it's out of neglect, right? If you look around at industry best practices, and it's easy because I come from the consulting side, but training for a workstation operator on, hey, this is what your magnehelic gauge should read as pressure, and that means that your ventilation's working properly, right? It doesn't even take a maintenance professional to just look at a gauge and say, look, it's between the green lines, it's good to go, right? And it gives them a little bit of ownership, right? So this doesn't have to be the most mind-blowing thing in the world, is really what I'm getting at. So in that, I welcome any interruptions from anybody at any point. Just turn on your microphone and say, hey, Phil, and I will immediately stop talking. I promise you. And whatever you have to say is you're on the floor, right? So this is interactive. It's as interactive as you want it to be. Or if you want to listen to me drone on, that's your prerogative, right? One of them is probably going to be more fun for you. Unlike your normal industrial hygienist, I try not to overload slides. I have like this whole 50 minutes is 10 slides. So a lot of it is based on that conversation and, really just some anecdotes from out in the field. So I welcome all the input. I will probably steal it and credit you later whenever I do this again. But, that's how these things grow, evolve, and we learn together, right? So why should we worry about this? So I'm from ACGIH. So, one of the things that I spend a bunch of time looking at is coming up with new TLVs, right? And hint, they don't normally get bigger, right? As we do more toxicological research, as we start to see some of these risks become exposed after a chemical's been out in the field for a while. The epidemiology. Nope. What's up, Ben?
You want to explain what a TLV is?
Yeah, for sure. There you go. See, I'm too used to that. So the TLV, if you find your closest SDS, which all of the mess on my desk has no SDSs, I'm terribly sorry. But if you flip to section 8, there's going to be a couple OELs, occupational exposure limits, right? First one is going to be OSHA's limit. Fun fact on those, they're based on the 1968 TLVs. And if you ever follow any of the cultural side of OSHA, which sounds weird coming out of my mouth, they're not even really big proponents of it, right? They basically just say these things should be replaced carte blanche, but it takes about 30 years for them to pass a new PEL. Just because of all of the work that goes into it, all of the SABRIFA process, the risk management or risk assessment that goes into it. It takes them decades to come up with a new PEL, right? So every year we move faster than the speed of government because we have the ability to do that. And we come up with our own limits, right? It's the TLVs, the threshold limit value, which really is a value based on a 40-hour work week and a lifetime of exposure, right? So if you flip to like benzene or silica or, whatever you're working with out there in the field, you'll find our most up-to-date value, right? And it's on those safety data sheets too. Right. So when you're looking at them, you usually see a much lower number, and that's just based on that new science. Right. So it's our job to follow that around. If if you really want to drill down to it, go to our website. The secret is that the TLVs are made up by a committee that's about 30 people. It's 30 max, and we usually float around between 25 and 30. But it's OC health doctors, it's pulmonologists, it's toxicologists, it's epidemiologists, it's PhD level industrial hygienists. It's always fun because I'm like the only person in the whole room who is not doctor something, right? So it's a really cool educational opportunity for me because I'm a nerd, but also, they can go back and forth with all of these specialties in a way that I don't think there's any other organization on earth that can do it, right? If you go to a regulator, a lot of times they kind of have a set toxicological, system that they'll use, and it's almost like an equation, right? So they're going to come up with a number based on that risk assessment equation. Us, on the other hand, we look at it and there's professional judgment that goes into it, right? Is it something, do we think that there's more uptake? Do we think that there's less uptake? We don't have to assume 100. So, it's a little bit more dynamic. In that same one, I'm going to throw a whole lot more alphabet soup at you. EPA is doing something funny now, right? For anybody who follows occupational limits or TSCA, EPA is coming up with limits for inside facilities now, right? They call them the NECL and the ECL. It's the new chemical exposure limit and the existing chemical exposure limit. But essentially, the last time that Congress looked at TSCA, they said, hey, workers are a protected population. EPA, this is part of your jurisdiction. Come up with occupational exposure limits for these things, right? And they're doing it at a clip, right? It's not the normal decades that it takes OSHA to do it. They're coming up with them left and right. Oh, hold on, Greg. I got to get chat bigger. There we go. So they're like PERC just came out with one, and essentially there's a phase out where that's just becoming illegal, right? Asbestos kind of went down the same route, but in the meantime, they have what they consider to be safe exposures, right? And we're working with them to make sure that that's a really refined process, but I can tell you it's also really risk adverse, right? Obviously it's EPA. It comes at it from an EPA angle where there's protecting vulnerable populations. They're kind of coming at it with that same mentality, right? So OELs, occupational limits, are just getting lower and lower, and there's more people getting into the game, right? So that's a reason to worry if your ventilation's working properly. If it's not working properly and you come in for one of these visits, then you're going to run into trouble, right? On the flip side of that, everybody's got report outs now that talk about, worker ESG, right? Safety's in it, environmental's in it. And those environmental ones are something that investors are looking at. So this is really kind of a corporate policy issue as well. If you start to neglect some of these components of your air cleaners or really just your system in general, you could go out of compliance with one of your permits, right? So it's important to keep these things at the forefront of your mind, and know that they're working properly to do what they're supposed to do and do it efficiently, right? Because that last one is the almighty dollar sign. So no matter what, it's a business, it's going to come down to that. Fans aren't cheap to run, right? Like they could soak up a bunch of electricity they could soak up a bunch of electricity working properly. But it's kind of adding insult to injury that you're spending all of this money to run a fan, and then your ventilation system isn't even working the way it's supposed to, right? As we kind of get more and more into the Internet of Things, if you go out there and you look around, there's really cool systems that are coming online now that specifically address this problem, and they're dynamic, right? The fan just doesn't turn on and run. It'll run at different speeds, ramp up, and there's automatic blast gates that'll open and close, which blast gate is just that thing that slides in and out and shuts off a whole section of the ventilation, right? If you've never heard that terminology before. But it's got a computer, right? So a piece of equipment will flip on, that blast gate will open automatically. Air will start flowing like right after it's turned on. The fan will ramp up and you're only burning the electricity you have to, right? So that is, it's always a concern, right? I'm not saying you have to go to the most high-tech option. I don't sell them for a living, so I'm not going to upsell you on it. But the reality is that even if you have a basic system for like one hood that's out there in your workplace, if you're running it just to run it, it's a giant waste of money, and that's not doing anybody any good, right? So I like to talk this up because it just kind of piques somebody's interest that, you can be the hero on some of this stuff, right? If you're out there on the floor, just these simple things can make you the hero, right? Even if you do end up having to call an engineer to help out with it, the fact that you could identify it and identify some of those inefficiencies is just going to make you out to be a better rounded professional, right? So first place I always start is the drawings, right? So there we go. Pause that one. This actually isn't part of the system, right? But at some point, some engineer thought it was a really good idea to design a ventilation system, right? Like somebody told this guy, you need to go out there and build something that works. And if there's any engineers on the call, I'm gonna need you to plug your ears for like 5 seconds, right? I love you all. You're the best. But at the same time, my favorite thing that engineers do is like turn something from calculus into just algebra for me, and they draw me pretty pictures, right? And they do this because that's the important information, right? Like they do everything they can to make it simple for me, the IH, to come in and look at it. So they have drawings. They've designed this. They know what it's supposed to look like. They can tell you what the components are supposed to be. And if you can get your hands on those, take them to your, well, don't take them to your grave. Keep them someplace that like you can actually get them, right? Because sometimes that engineer that put all of that tender loving care into drawing your system up and making it efficient and saying this is what's going to work perfectly and it meets all of these standards, sometimes the engineer that follows them couldn't care any less about that thing, and it goes into a drawer, and then that drawer gets thrown away like along with the rest of the filing cabinets because everything else got digitized, and you would have to dig through like a mountain of garbage to ever find it again, right? It's there. Those original drawings are there. They're supposed to be a living document, right? So anytime there's changes made to it, you should be able to go back to those and see where some of these ideas were, added, taken off. But I can tell you one of the most important things is it'll at least tell you what kind of fan is there, what the air cleaner is. It'll tell you what the original ductwork is. And if that thing's been chopped up, like finely diced and things added all over the place, it'll tell you at least where you were supposed to start, right? And that's half the head scratching, right? I've gone into places, clearly those are on time, sorry. I've gone into places where I can't tell what the original ductwork is anymore, right? Workstations have been moved around, they've been added, there's been new drop points put into the thing. Where duct is run now makes zero sense. I have one place that I went into where ductwork came in, turned, and ran the length of the building down a wall, made a turn to go through a newly cut hole in the wall above a forklift door, and then came all the way back through the facility to turn again and then go down to the workstations, right? And I refuse to believe that an engineer thought that was a good idea, because just like straws, if you duct tape 20 of them together, it's going to take a long time to siphon whatever you're trying to get, right? Adding that much duct work is not a good thing. So always keep those drawings. And on the back end of that one, if it was a good engineering firm that originally did your installation, they're going to have something called the tab report. It's testing and balancing. So they're going to come out, they're going to check all of the airflows at all of the drop stations and say, this is how much air is flowing through here. This is what it should be. This is what it was designed to do. And here's a nice spreadsheet of all of those, right? It would definitely make you look like the hero, because all you have, I can teach anybody how to take those measurements in about 5 seconds. And if it matches close enough to that tab, you can say for sure that your system's working properly, right? That's all that MagnaHelic gauge is doing for that end operator. So I always start here because they get lost, right? I've gone into so many places where even a brand new system, no one knew where any of the drawings were, right? I'm trying to figure out what the heck they designed this to, why they look like they do. You know, shoot, there was one place that almost sucked a manometer, the air gauge, out of my hand because it had so much power and it was the most ineffective hood I've ever seen. And I asked them, like, hey, this I'm testing to make sure this thing works. This is the first time it's online. Where's the drawing? And no one in the whole facility knew because the engineer that commissioned it quit halfway through the project, and everybody just let the engineering firm that was building it build it without asking any questions, right? So always keep those things. Find them, covet them, make them part of your filing cabinet, right? So now all of that, I blathered on enough about that one. The system, right? Like, this is what we're here to talk about. This is how you can troubleshoot it, right? Don't overthink it. There's only a couple of things there, right? So really the heart of all of it is the fan, and all it does is spin, right? Like, it's impossible to not appreciate for its simplicity, right? It is a motor. It should only run one direction, and that will eject air out the side. And that is the most complicated part of the entire ventilation system, right? Before that, you're most likely going to have some kind of air cleaning system. If the fan is the most complicated because it's moving, this is second most complicated just because, I don't know, they're big, they run different ways, and sometimes they get funny, right? So I'll keep that simple. But everything on either side of that is just a straw. It's a straw, and then it drops down to a workstation, and there's some kind of hood there, right? So we'll run through all of these, but I know it's daunting. I know it can get daunting because the stuff runs all over the place. You don't know where it's supposed to be going. But if you just think about it that way, that makes it a heck of a lot more approachable, right? So in true IH fashion, I'll start at the workstation and then work my way back through it, right? So hoods are they're the most abused part of a system, right? Because it gets built. Ben, to your point, like, an IH comes in with this great idea of a beautiful hood that's going to work perfectly, or the engineer comes in with exactly what's going to get the right pickup. They build this thing, and then somebody has to actually work next to it, right? And that's usually where it all just goes to pot. Because the thing's designed to suck air, and it's not really designed to be integral to work sometimes, right? So there's a couple of things that you got to look at to see if it's potentially your problem, right? First and foremost, always look for modifications. If you get out there and it looks like somebody took a torch to sheet metal, that could be part of your problem, right? Like, a hood is not designed to be torched and put holes through it because of that picture that you see. I got it on multiple screens, but that picture that you see there, right? If anybody's ever picked up a vent manual or just Google flanged hood, this thing kind of is a crude drawing of how much air drops off, or how much air velocity drops off the second you get to the other side of the duct, right? Yeah. Perfect, right? That's exactly it, right? So at about 50% of the duct diameter away from the opening, right, you're already down to 30% of the air velocity that you have inside of the duct, right? So placement is huge for these things. You'll always see welders that look like this, right? If you go out there into your facility and you see this happening, that thing's not working. And there's nothing wrong with the system. You're getting a weld haze because that thing has to be placed strategically next to the weld for it to work, right? It has to be close. You have to kind of recalibrate it constantly so you're not screwing with shield gas. That's why every welder hates industrial hygienists. But that is what it is. This thing is a well-designed hood that's just in the wrong place. It should always be about a foot and a half away from whatever you're welding, and away from your face and on the other side of the weld, because that stuff will go up because it's warm. So it goes up, and it should just go straight into that hood, right? That's never how it works. I've never been to a weld shop where there's not 3 stations that just have that hood thrown into the corner with, you know, the unit running, right? It's sucking air, but it's pulling it from 10 feet away from where the guy's welding. And you don't really need to spend money on a lab or an industrial hygienist if that's what's happening, right? Clearly, it would work better if you moved it. You don't need me for that. So I always tell people, check for those 2 things, check for those holes, check to see what it is. Even with the modifications, you know, if you can duct tape cardboard over it, and it goes back to working absolutely fine, then, you know, that might be the time to call in an engineer to redesign that thing. But, you know, it's that could be your reason, right? If it's just rolling right out a hole that was cut inside that hood, that's a big possibility that it's your reason, right? So at the end of the line, check for the modifications, check for placement of the hood. Next one that I like to jump to is the fan, right? Because if the hood is perfect and in the right place, everything in between it should just be like empty ductwork, right? So the next place where you see problems is the fan, right? Because it's the only part moving. Everything else is passive, and everything else is usually tucked out of the way enough that somebody's not taking a blowtorch to it. So you could skip right from where the operator is over to the fan. If anybody has never had the good fortune of cracking open a fan, it is not complicated, right? You'll see the ductwork come in. It's going to suck air in that. The reason that it sucks air in that is because, forget you guys are over here, you know, this thing just spins, and all it is a paddle wheel, right? So it will spin that air, and as it hits the side of the casing, just throws it right up out of that ejection duct, right? And that's the whole way that it works. The motor should spin in one direction. It's just ejecting air straight up, and that creates a vacuum in the middle of that, which sucks that air in the side. If you don't feel like thinking about that, don't worry about it. It goes in one side, out the other, right? Here's the problem, and I run into this one a lot. People will get a new fan. They'll size up a fan. Fan will burn out. You know, it's for whatever reason they had to replace the fan, right? And now if there's any electricians on the call, it's your turn to plug your ears really quick. But I've never met an electrician that wired something incorrectly if you ask them, right? Here's the problem with this. These are 3-phase, right? And for anybody that knows just enough about electricity to know not to touch the fence like me, if you wire 3-phase backwards, that motor will still spin. It will just spin the opposite direction, which kind of makes that fan useless. And it's weird. It's deceptive, right? If you were to put your hand near the exhaust on that fan, air will still be coming out, but not as much as there should be, right? It'll be about 1/3 of the airflow that you're looking for. So it's important when these components are replaced, you know, make sure that you let operators know that they were replaced. And if they see a reduction in the suction that they're getting at the hood, this is probably the likely culprit, right? And it's just as easy as convincing an electrician, try wiring it the other way and see if it works better, right? Because that thing will be spinning the wrong direction, and you're going to spend a bunch of money having somebody come out there to stick a pitot tube in the tube in front of that to measure airflow, or to measure air pressure rather, and they're just going to come out and tell you to have that electrician double check their work. So start there. If it's not a new fan and you see a sudden reduction in suction that's at the operator station, another thing to check is just for like random problems that come up with motors, right? For anybody who's ever worked on anything with a belt, those things stretch, they start to slip. Sometimes the belt doesn't go on. I've heard of engineers that have been called back out to a facility after everything is installed and they said your design doesn't work at all. This is mind blowing. They got out there and it was just because the motor was installed, the fan was installed, and nobody put the belt between the two, right? So they paid for an entire engineer for an entire day to just have him come out and go, there's no belt, turn around and go home, right? So check those things. If you start to hear that squeak, that's your belt slipping. So check for some of those, right? That'll be a slow reduction over time. Honestly, if you have those drawings, if you have the tab, it probably has a maintenance schedule on that, right? What's up, Dale?
Yeah, I was wondering, are you going to discuss the ACGIH's ventilation handbook, which is practically the Bible of industrial ventilation?
So that's what these are back here, right? So I'll talk about it. I try to keep this one a little bit more basic than what's in that, right? But if you have questions about it, I'll stick around afterwards for as long as you guys want to hang out, and we can talk about whatever you want to, right? But
No, I mean just the fact that it exists, and if anybody is really interested in, you know, the basics of industrial ventilation, that's, like I said, basically the Bible of industrial ventilation. Also, if you could discuss the problems with canopy hoods. One of your pictures showed a you know, like a slot hood on one side of a vat versus a canopy hood, which if you have to work over it, it's really a bad thing to have.
Yep. Yes. So we'll go back to that one. So two things. Dale brought it up. I try to keep sales out of it as much as I can, but we have a couple things that if you're inclined, if this kind of wets your whistle, we have the vent manual, design manual. We just came out with a new one last year. And to Dale's point, people call it the Bible of ventilation, right? It's a cool group of engineers that get together, set up really all of the recommendations that are used pretty much anywhere for ventilation design on these ones. So that's where that drawing comes from of the hood. And, you know, really it's, I can't emphasize enough. I have even a first edition back there, right? So it's been, we're in the 31st now. One comes out every 3 years. So with new updates. So pick that up. That's a good book. Honestly, an even better one for most maintenance departments is there's like a companion guide. That's the operations maintenance manual. And that'll go into some of these checks, some of the best practices for what to have in a program, that kind of stuff. And so I always advocate start there because it helps you with really keeping your system running. And then once you get that stuff in place, the design manual is where you're going to go for a lot of this stuff. We also have some education on it. It's, and this is not my words, a couple of people have said it, the best ventilation course that anybody's ever attended. It's 4.5 day that we do in Cincinnati. But it kind of walks you through designing an entire system, right? So it's this on steroids. It gets in depth. And honestly, you can walk out of there and probably go toe to toe with any industrial hygienist that is out there in the field, right? I mean, practice is going to help cement it into your head, but it is definitely all of the stuff that you need to be able to walk back to a system. Yeah. So Dale's other point, I didn't really touch on it because it's not part of troubleshooting the system, but if you look at that welder over there, right? We have this problem all of the time. Direction is key whenever it comes to actually any hood, not even just canopies. If it's like a paint booth, like all that is a giant hood that you stand in, right? Problem is if somebody's working over their work and you're not removing the toxicant before it gets to the person, then they're going to breathe it in, right? I don't care if they're wearing a weld mask, if they're wearing whatever, it's going to come right up and it's going to go into their breathing zone. And that's the whole point in having ventilation, is to avoid that, right? So always look for that direction of airflow. Canopies are kind of there just to collect heat, not make a building miserable, because they're always over a vat and it just takes the plume and directs it like outside, right? These weld hoods, same way. I see them like that all the time. If they're pulling it like up towards the person's head, it's kind of making the problem worse because they're breathing in as much can be concentrated in that area and then it gets removed. The paint booth, it's weird to think about, but if air is flowing from back to front, people should be working sideways in that thing because that's going to move the air in front of them and over towards the screens, right? If somebody's standing facing the screens, it'll create an eddy and actually like make a miniature buildup of whatever they're working with, right? So if it's a solvent, it'll just build up in front of them. So, yeah, always look for the placement on those. Part of that placement is getting those right. Dale?
Yeah, and real quick, there are, if anybody has welding activities in their business, they make the local snorkels that are like in that welding picture. There's actually snorkels that have light sensors that will reposition the snorkel over where the fumes are being generated automatically, which is some pretty cool technology that's out there nowadays. And also another consideration that's really important is where the makeup air is coming from. And, when you're sucking air, you want to have laminar flow in order to remove the contaminants from the breathing zone of the worker. And you need to have a good makeup air. If it's in a small room and it's just sucking, you can generate so many eddies and so forth that it causes problems. I see this a lot in indoor firing ranges, trying to control the lead from the primer that it has lead in it from firing bullets. And you really want that flow to just be laminar. So you need to have good makeup air.
Yep. Yeah, absolutely. And that's kind of the one slide that's not in this, right? And I always add it right to the end, but that makeup air is key, right? Because you're sucking air. And it's no different. Take a straw, put your finger over the end of it and try sucking air through the straw, right? Like, not going to get very far. So if you have a facility where to swing a door out, you got to throw a shoulder into it, you got a problem, right? Because if there's no air to suck because that's a negative pressure in the room already, it doesn't matter what you do to the system, it's not going to work, right? You have to have something that is bringing air in at the same rate that it's going out. And to Dale's point, like it's the direction of it as well, right? It's really important. I mean, we think about, I hate to bring it up, the virus that shall not be named, right? But when everybody is a point source, everybody paid attention to the direction of airflow, right? And this is no different. Every one of these stations is, if it's a weld station like this, they're the point source. It has to come in, flow to that station and go out that tube. If you've got too much air coming in and it's like overriding what you're doing with the hood, it's just going to mix in the general air as well, right? So direction, speed of that makeup air, it's all important. Even that, I was at I was at conference 2 years ago. I was standing there in the booth and, I was just starting to talk with somebody and the guy came up and said, hey, we have this problem. And he actually said, like, this isn't to boast, but he said, people are complaining that, all of a sudden they're getting sore throats and, the ventilation is messed up, but I know that that's total bunk because we just put in fans to help offset some of the heat, right? And just because I'd run into it out in the field before, through experience, like, oh, which way are the fans pointed? Like, are you bringing air in or out? He's like, oh, we're removing the hot air to outside. I'm like, oh, well, where did you put the makeup louvers? And he just kind of stared at me. Like, oh, well, you put big fans on the wall that are made to move a bunch of air out of the room, created a negative pressure on the inside, and your ventilation system is now working backwards, right? Like, if there's no makeup air, it's getting sucked. All of that's, I don't even know what he was generating, but I just said it's coming back down through there. You're overriding the small fan that's supposed to be moving a small amount of air with this negative pressure, and you're just sucking it back into the room and out the wall instead of through your ventilation system, right? So goes two ways. Makeup air for that. Be careful what you're doing with, I know everybody's worried about heat now, which like we should be because nothing's getting colder. But moving that heat is another one of those eddies and is another place where you're creating negative pressure, right? So do look for those ones. Yeah, you're absolutely right. I keep those ones out of here just because I try to keep to the troubleshooting aspect of it, but that will create problems as well. Yeah. Fan, like I said, look for those slips, look for, if it's a new fan wired backwards, that kind of stuff. Duct. So in theory, this should be like a slam dunk, right? If your fan's working right and your hood is positioned properly, isn't overly modified, anything like that, in theory, the system should be working pretty well. The problem is that people start to screw with these things, right? Like this is a very passive component of the system. It's just a tube. But there's a million things that somebody can do to this thing, right? One of them is, in this picture, you actually see them blast gates. Like I said, they can open and close based on where it's at, especially in some older systems, they were used to balance it. So you just oversize the fan and then you close that thing enough that you get the right suction at the piece of equipment, right? So essentially you just halfway close that tube to get the right airflow. Problems come in where if you don't lock those and mark where they're supposed to be with a Sharpie, somebody comes in and they decide they want more airflow on their machine, or they decide that that one over there doesn't run a whole bunch, they're going to shut it. They start changing where all the air is going to flow from, right? Because if you shut off two tubes and open one all the way up, you're going to get a bunch of airflow through that. Somebody's going to come back to work on another machine, have zero airflow, right? So make sure you mark those, make sure you lock those things. And by lock, I don't, you don't have to lock it out or anything like that, but just put a bolt through it, like drill a hole, put a bolt through it where it's supposed to be, and then Sharpie it to stay there. And if you ever see that thing become unbolted, then it's probably in the wrong position, right? Damaged ducts. I know this doesn't happen anywhere in anybody's facility. Every single fork truck has a perfect paint job that's never been scuffed up, but I've heard horror stories of out there in the world where fork trucks have found things and bumped into them, right? And sometimes the duct that's way up high that wouldn't get hit when nobody's running around with the forks up gets a little bumped, right? And that might not be catastrophic. You're still going to get airflow through the thing, all of that, but it does create a little section in there where the airflow isn't perfect, right? Like what we're shooting for is the air not running into anything, because when it runs into something, it moves, and that takes some of the energy away from it versus just moving straight through a duct, right? So those damaged ducts can start to add up after a long time. Those blast gates are a big one. Blockages is another one, right? When we do that fundamentals of ventilation course, people leave on day 4, and it's our job as staff to mess with the thing as much as humanly possible, right? If you go out there in the world and you start staring down some of these ducts, you're going to find beer bottles. I found beer bottles shoved in them. I found gloves shoved in them. I've found, pieces of lab equipment sucked up into them. I've found pretty much anything you can imagine. Wrenches in there, like it just went down the tube and just kept going, right? So you start to get some blockages like that, especially with the gloves or something that's bigger like that. It'll get in there, it'll get caught and won't keep going, right? So it's going to create a backup point where dust starts to build up. New additions is another one, right? So I had a place that, they had a couple fans that were running, and if you picked up the raw material was just like a silica flower at the end, you could pick it up and drop it right in front of the hood, and it didn't move. Like it just fell straight down. With the fan running 2 inches in front of the hood, it did nothing, right? But they had a lot of additions put onto this thing, and a lot of them were this kind of tubing right here, right? That stuff's great because for something that's mobile like that, the hood needs to be in a couple different places. It gives you the ability to do that. But also that stuff is horrible for airflow, right? Like if you think about that, if you plugged up the end of it and put a vacuum on there, it would just suck up like a slinky, right? And that's from the air pulling all of that plastic in. It's from little catches along the edge of it because it's bumped. Like adding that stuff is a killer for potential energy in your system, right? So if you get some of that where they just drill a hole in the side of a duct and shove it in there, it's a very inefficient connection with very inefficient ducting, right? And it will take a lot of energy. If you do that a couple times, it's going to lead to trouble, right? If it's not designed for it, it shouldn't be there. So you'll run into that. People just try adding ductwork and they think, well, whatever, the fan will balance it out. But and to a certain degree, the fan will. But after a while, it'll be the killer, right? It's the same size fan trying to do more work, and that, you know, we're in a day and age where we all have 3 jobs, but if we added a 4th one, like the 4th job isn't getting done as well, right? And that's just the reality of it. That's what we're doing to these poor fans. Replacement not in kind can be another issue. So if it's, you know, if all of a sudden you decide you don't want this workstation, but you want it moved over there, adding duct, moving it around, that's going to mess with your potential energy. And it kind of takes not for one movement like that, it doesn't take killer amount of calculations to do. And if you honestly read the design manual, you could probably change some of those yourself, just because you could look at it as, you know, 2 components. But look for things that just don't quite fit, right? If it's a different kind of elbow, God forbid somebody takes what used to be a nice rounded elbow and they just make it an L, right? You got to think about what's happening in that. The air is coming in, it's just slamming into this wall, spinning around, and then trying to go back out that way instead of coming in and flowing at a nice angle, right? So look for things that don't belong there is another one. If you had fan maintenance recently, this is no joke. This blockage can happen, right? If you got a kind of dust that maybe has some kind of resin mixed in with it, if a fan was running backwards for a long time and didn't have the right amount of suction, you know, you'll get buildup like that inside of a duct. I'm not saying that they have to be cleaned every year or anything like that. I'm not trying to sell that service either. But if you ever, and this is scientific, right? Take a broom handle, and if you can walk up to the duct and smack it and it's a hollow thud, like it's full of something, right? And that's an indicator right there that that fan might as well not be running, because that air is not flowing, and you got to take it apart like that and get all of that stuff out of there for that to work, right? But you now know it's a problem just by hitting it with a broom handle, which if you've ever met me or had to work with me, hitting stuff with broom handles is like right there on par with problem solving, right? Just don't hit it hard enough to dent it like that, I guess. The next one, air cleaning devices. You know, this is one where you can crack one open and look inside of it while the system's off, right? They're usually not, the majority of them are not overly complicated. It's just filters, right? So if you take a quick peek inside of that thing and you see all the filters are destroyed, it's probably not working, right? And you're getting dust ejected, and that's why. A lot of times with those sock filters like that, it gets diagnosed, somebody knows it ripped because all of a sudden they see dust flying out of there, right? But some of the stuff that I've seen out there in the field where it's not diagnosed that easily, you know, this one, the one that I put this picture up is a great example. If you see bending like that, the great thing about this is, you know, and everybody's becoming more aware of combustible dust now, but you're taking something that probably wouldn't have lit on fire in your facility, sucking it into a tube, sending it into, you know, a big room like this essentially, and concentrating it, right? If you get static buildup in there and it just reaches that ignition point, you get a boom that goes inside of this thing, right? And you'll know that that happened because you'll see this, right? It'll be distorted, it'll be pulled on, seams might be busted open. If the thing was designed to actually, you know, withstand one of those things, you might have a blowout port that's just all of a sudden open. But somebody might not report that something weird happened, right? If it happened outside of the facility at night on second shift, somebody heard the dunk, looked around, didn't see anything, nothing inside was on fire, they might just let this happen, right? So keep an eye out for your air cleaning devices, something funny like that. If you see holes around the doors, that'll happen a lot. You know, they're sealed up usually with a rubber seal. If you see that rubber just hanging down off of it, that's a quick maintenance thing that you can get somebody on. It's not rocket science to put one of those back up there, right? So look for the seams, look for the doors, look for the vents, right? And then the last one is where the exhaust actually comes out of the fan, right? Usually this is a short run. There's not as much stuff. It's tucked out of the way, so we don't really see it get hit with forklifts or anything like that. But weird things happen when the system's off or, in the middle of the night. So if you looked at all this other stuff, it might be worth climbing up on the roof and just taking a quick look at these things too, right? If somebody, and this is one I've seen, a well-meaning maintenance guy, they're complaining that rain is getting down inside of a duct. So what do? They go up there and fix it by just putting a cap over it. Well, take a straw, cover up the end of it, and try blowing out of it. And that's what you just did to that fan, right? It's some will escape, but not at the rate that you want it to. So you want to see preferably something that looks like that. And really all it is a big tube around a smaller tube. And when the rain comes, it'll hit the side of the big tube, roll out of it, you're fine. But the smaller tube inside will be where, the air is actually ejected from. Look for any damage to the ducts that are going into the fan up there. Sometimes, this was a weird one, I saw an exhaust that looked like that one that's there on the left, and an animal had gotten in there, and then they restarted the fan, and it was stuck up against the screen that was there, creating kind of an airflow issue that I don't know how long they had that airflow issue, but again, it was something that nobody inside complained, right? So that's just stuff to look for, right? And Russell, thank you. That's the best compliment an IH can get, right? That just made sense. Because that's really what I'm hoping for out of this, right? It's not using a pitot tube. You don't need any of our books. Again, I'm a terrible salesman, but for a lot of this stuff, it's just when you stop, you think about it, you apply just a little bit of logic to it, you can go pretty far with these systems, and you can protect people in your workplace a little bit better, right? So that's kind of the end of the technical part of it. As soon as I find my cursor, there it is. That's my contact information, right? That goes right to my cell phone. So leave me a voicemail and I'll get back to you, because I'm usually in a meeting for something, but I'll talk with anybody about IH issues all day long, right? It pulls me out of the management side of things and gets me back out into the field for a second. So, and then that's my email address. So, Dale, what's up, dude?
Yeah, regarding exhaust, just for a lot of times, safety people are tasked with environmental issues as well. If you've got exhaust in an industrial setting, you may have needed to have a permit. And our local agency is the Clark County Department of Air Quality, and you would need a permit. You possibly would need a permit depending on how much pollutants you're exhausting to the outdoor air. So that would be one thing. Another real easy thing that I find for evaluating ventilation systems is either have a smoke tube like we use for respirator fit testing, and you blow the smoke at the intake, and you can just visualize exactly how your unit is working. And if you don't have smoke, most of the time you have access to toilet paper. And what I'll do is go and grab a little piece of toilet paper and take it down to one ply and tear it into a strip. And that is a great telltale, because sometimes it's hard to, just by feeling it, to know which direction the air is going. Mm-hmm. So you could use something like that to see, if your ventilation is working. It can also be useful for indoor air quality for determining the pressurization of different rooms within your building.
Yeah, for sure. Yeah, I go even less technical, dry ice, right? Like you can get that while you're just, up here, Meyer. I'm not sure if Meyer's down there, but wherever you're checking groceries out, right? Just get the smallest amount of dry ice you can get in a cup of water and you're good to go, right?
Also, we have an interesting new issue that's going to be coming up is marijuana odor smell. We are one of the first cities or states to allow legal smoking lounges. Ooh. And the people that are regulating it don't have a clue how to control those odors. So it's going to be really interesting to see what they come up with. They initially were saying you needed to have like 60 air changes per hour. And I was like, you guys have no clue what you're talking about. So now they're just leaving it in the hands of the engineers that are designing the systems for these new facilities. So if you start smelling a lot of marijuana odor, you may be next to a smoking lounge.
They just passed that statewide in Ohio, right? And that's what I'm waiting for. Well, you still have to stay outside. There's no smoking inside, but outside and every one of the buildings, right? That's
well, the issue is right now you're not allowed to. You can buy it as much as you want here in Vegas, and there's actually cannabis tourism, but you're not allowed to smoke it except in a private home. But people are smoking in the hotel rooms, so now they're figuring, well, I mean, might as well make some more money off of building lounges, specifically for smoking marijuana.
Can't lose that sweet revenue, man. I think
Nope.
so. I'd have to look back. It hasn't been in the manual for a while, right? An ASHRAE hasn't. It might come back. It might come back as a thing for the number of air changes per hour. But that's a great example. I mean, every time I've ever been to Vegas, it still blows my mind that there's the smoking lounges like in the airport, right? And you guys might have got rid of those.
No,
but no, still there. Okay, yeah, that's a weird. That's a cool. I guess weird. It's a cool engineering thing to look at, but you can see how efficient it is. Every time somebody cracks that door, you get the whiff of it, and then it disappears again, right? So yeah, that one will be a whole new level of an odor, right? So
Who else, maybe from the non-IH practitioner standpoint, has got some questions or takeaways?
that's too easy.
I guess so. But I mean, I'll just chime in. I appreciate that they're just these, just think from a non-IH perspective, because that's not what I do. Let's just think about the basic components of what each part of this system does, and what's the simplest way to determine whether it's going or not.
Yep.
Trying to be efficient before we call in the big guns.
Yeah, and that's there's definitely a time and place, right? But I stumbled backwards into industrial hygiene because I didn't know what I was going to do with my life, right? So I accidentally went to grad school to be an IH. And then built from there, right? My first role was more safety, and then I kind of built backwards into it just because I realized I liked the biology component, right? Like I'm still a nerd, but it's everybody can do it, right? Everybody can do it. How's it going, Craig?
Oh, it's going fine. We're having a beautiful day up here in Alaska, about 4 feet of snow. Definitely not what's happening in Vegas right now. So, yeah. One of the areas that I work in is aircraft air quality. And early on in the chat there, I put in a comment about the cabin air quality organization based out of London that I belong to. And they have a really good conference that they do every 2 years. If you get a chance, want to go to Kensington, London, Queen's College, and all that, sign up for that group, and it's really good. It's basically the sort of thing you're talking about, but you're focused on buildings rather than aircraft, and it's a big problem. Almost all aircraft, with the notable exception of the 787, use packs that take bleed air from engines, and they have all the unburned hydrocarbons that then go with little or no filtering into the cabin, and people get acclimatized to it very quickly. Within 1 minute, you lose that dirty sock smell, but you're still getting all the pollutants. And so we've had a lot of injuries and deaths that have actually occurred from this, and there's not a lot of attention being put on it. Are you familiar with this?
Yeah. So I've never had to deal with it personally, right? I've never had to deal with it. I know some of industrial hygienists that, do have that. And it's weird. Like you said, it's really sporadic, right? You never have an industrial hygienist when you need it. That's just the name of the game whenever, that's how we operate. We show up 5 minutes after the problem ended, and that's the fastest we get there, right? But I know the union for air. Okay, what's the term for an air assistant?
A flight attendants, AFA.
Yeah, flight attendant. There we go. I can only think of a very old school, not
that's my wife. She's head of cabin safety for Alaska Airlines in Anchorage.
Okay, there you go. So yeah, the attendance, I know that it's a big issue for their union too, right? Like
That's absolutely right.
It's noticed. And there's a few indicators that people use in that situation, but yeah, it's a weird mishmash of on-burn hydrocarbon coming from that Jet A, right? So yeah.
Or hydraulics getting overheated and in the cabin, all kinds of things.
Yep.
Or de-icing fluid on pushback coming in. There's a lot of really bad stuff coming into aircraft cabins.
Yep. Nope. And, even if it's not coming from outside, right, there's been, and this gets nerdy, but, since that virus, just the study of how air flows through an air cabin, right, like with the fans and where the uptake, points are in it. It's interesting. It's interesting how air flows through there and where it comes from.
Well, it's gotten worse because in the name of efficiency, they're recirculating the air where until about the past 20 years, the air made one pass through the airplane. It came in from the packs and whatever condition it was in, went through the airplane, was regulated by the outflow valve and went out in the world. But now that's not efficient. And so they recirculate the air. It goes round and round, supposedly through HEPA filters, but they may or may not be in place, and you get to breathe everybody else's diseases. You're in a germy tube for 6 hours at a time.
Yep. And even if the HEPA filter is there, hopefully it's like installed well enough that it's going through it, not around it. Right. That's a fun one.
Yeah. Thank you.
Thank you, sir.
Philip, what are some of the industries, I guess within general industry exposures, construction is probably a whole nother beast, but within general industry settings, what are some of the most common workplace types where you see these easily diagnosable system failures that again, non-IHs would be encountering?
So, okay. I'm going to flip it around. I can't think of many where you don't run into it, right? It's because they're so commonly installed, right? Especially in what we consider the more dirty industry, right? Like if you're foundries have gotten really good since the silica's been buttoned up. They spend a lot of money on their ventilation systems, right? But I'm thinking even back to the paper mill, right? I mean, I've been into resin facilities. If you're handling something, there's not too many places where they don't have a paint booth or they don't have a welder. Like somebody has some kind of ventilation someplace, right? Even if it turns out to be something that you're using more for indoor air quality, some of the stuff, you can apply it backwards into HVAC if you want to, right? There's an air intake, there's the air treatment, and then there's the ductwork. And it's just working in reverse. So if you're not getting the airflow in you're supposed to, it could be the fan, right? So Lisa's going to throw stuff at me.
No, you know what? No, this was great. It's always such a good reminder of like some of the things that are just simple to check. But I think, at least some of the things that I have found just working in manufacturing, and we now going from the paper mill to beverage manufacturing, which is handling dry ingredients. You have a lot of airborne really, really fine particle ingredients. So we have ventilation systems. But one of the things that I've found is the maintenance of them. So people think you just put them in place. So you mentioned some of it, like the motor is not turning properly. They have some sort of filter system on there, or it's vented back into the same room. Mm-hmm. So it's just sucking and blowing up above, and then it just kind of all trickles down from the ceiling. Or again, people don't understand, like in some states, like I think Dale was mentioning something about Clark County, is just that, we have our own air regulations. So you can't just vent stuff outside and now have all this stuff discharging into the atmosphere outside. Yep. So making sure of that, but it's a good reminder of just checking, like do the basics, like check your system. Are you moving air? Can you feel the air moving? Mm-hmm. If not, is it blowing? Do you see that sort of cloud still around the worker? Like that's a good indicator that there's still work to be done. So I think these are just good reminders about, I mean, I'm a nerd too. I love this sort of stuff. I love talking about things that will just make a workplace a little bit safer for employees, especially when they don't realize. And I'll give you an example. We did some hex chrome sampling at a previous workplace, and the guy had been a welder for like 35 years. He's like, I've never had anyone do any kind of sampling. He's like, I always wondered if I would end up like dying from this. And so that's pretty sad because our workers they're not knowledgeable in some cases about the hazards that exist in the workplace. So, doing this stuff is really important to make sure that we're, saving lives and making sure that they have a good, healthy working relationship for a long time,
Absolutely.
So loved this. Thanks, Phil.
Good. Thank you. Yeah. On that environmental side, I always, there's the not technical way for that too. Like, you shouldn't really see your exhaust, right? Like, that's an opacity problem. like unless it's steam, like you probably have an opacity problem if you can look at the end of the exhaust and go, look at all of that stuff, right? Something's not working. So, well, good. Thank you guys so much for having me. It's always great. Like I said, I love getting back down into the weeds. So if anybody has any follow-up, feel free to give me a call. Shoot me an email on it. If you do pick up a version of the vent manual, shoot me an email on it if you have any questions about what goes into it. That's another one of them. It's great to sit in on those meetings because it's picking the brains of like every ventilation engineer that I can find, with a whole bunch of doctorates there too, right? So it's great to watch these people work. So I can help with most things, and if I don't know the answer, it's cool because I know the person that came up with it, right?
Yeah, thanks again, Phil. This is a very, very important conversation today, and I think you presented in a easy to understand way for everyone, and really helpful for us to hear this. Before you go, is there any updates from ACGIH that you'd like to share since we got you today?
Yeah, so we stay busy, right? My kids like to point out the gray hair, but it's coming in nice and thick, right? So I got that going for me. So just this past year was our first year where we actually have 2 comment periods per year now. And the problem before was, so our volunteers would write a documentation and come up with a TLV, and it would go to the full committee, but the board only voted on stuff in December, right? Which really for some of the stuff we're dealing with now, like fentanyl, UV was a big one whenever that virus was out, right? Everybody wants to use 222 now to sanitize surfaces and air. But we wanted to catch up a little bit with some of the new research that was specific to that band, right? That band of ultraviolet light. So we said, doing this once a year where stuff only comes out for comment in the spring and then nobody sees it finalized until the next year is just not responsive enough for our constituents, right? So we changed it up. We went to 2 comment periods per year. And the great thing about that is we can write it, we get it out in the middle of summer. People have the second half of the year to comment on it, and it becomes a TLV like potentially that same year, right? As long as we can get all of the stakeholder feedback addressed and integrated into the document, it comes out that year, which gets it put on those SDSs that much faster, right? There's a whole year that we removed from that lag time so that people are using the most up-to-date information like immediately, right? So I'm proud of that one. That took a big haul. On our membership side, we've switched over, and I like to talk this one up because, like I said, if I can do it, anybody can do it. And like, I'm trying to get the dentists of the world and convert everybody to being an industrial hygienist too, right? Like it's not mutually exclusive. There's not an invisible wall there that, we should be building. We should be taking that down, right? So we started offering an organizational membership to ACGIH, which, depending on the number of people that are in your organization that you want to join, really takes that price and rolls it backwards, right? And it still comes with all the same benefits, right? You get the book full of TLVs, you get 20% off all of the other the documentation, all that kind of stuff. The vent manual, you get 20% off that, and free shipping if you're a member. And we actually took, so if anybody has ever gone into like an old school IH office and looked at the wall, there's a bunch of those like 4-inch 3-ring binders full of paper. That's all of our old documentation, right? And that's horrible because I know I owned one of those and it just stayed in the trunk of the car, and I'd drive around to clients and have to go out there and pull this out and like do it. We took all of that, digitized it. So all of our documentation is on our website now, right? And that's free access for all of our members. We also still do the action level, which is really just a way to kind of force people into reading the journal and staying up to date on new IH research, right? But it counts for the CSP and the CIH. You get points for free for doing an online quiz with the journal, right? So we put that out every time there's a issue of the journal that comes out, and they're not mind-blowing questions. It's just kind of knowledge checks that you read the journal, right? So we're really trying to break down that barrier. So, I encourage people to check out the website, look around, stay in tune with what's happening with the TLV process. And if you ever have any questions, make sure you ask, right? That's the big deal. Yes, sir, Dale.
Yeah, your salesmanship is lacking again with regards to the TLV booklet. We call you guys write the ventilation Bible. Well, the TLV booklet is the industrial hygiene Bible. If you get the TLV booklet and were to read everything, because it doesn't just address TLVs.
Yeah.
It addresses, heat stress, ultraviolet light, noise, radiation, ergonomics. So just about anything that has to do with industrial hygiene is in the TLV booklet. And it's still under $100, isn't it? Or is it over?
Oh yeah,
100
absolutely. It's not even $60, right? That's not even 60. And it's one of those free member benefits too, right? We've kept that one. You can either get it. We sell digital through TechStreet, which a lot of people like bigger corporations want to buy it that way because then they can push it out to all the sites right away. That's a little bit easier, right? But we'll still send you paper. There's just kind of an email that goes out, says, would you rather have digital or paper? You pick paper, we ship it to you for free. You get to build a giant bookshelf of them like I have over there that go back for as long as you've been interested in industrial hygiene, or in my case, since I was born. That's always fun. We change the cover every year, so you get a new color. It's exciting.
I had a question too. Is there the Mine Safety and Health Administration is so far behind that their PELs are the 1973 TLV booklet?
Yep.
Is there a way to get a 1973 TLV booklet?
So theirs are, and actually, so OSHA's in the same spot, right? OSHA is the 1968 TLVs, unless like they've gone through that decade's worth of updates. So we have, we have the PEL, and it's included. We sell a separate book called the OEV Guide, and that's actually side by side. It's OSHA, it's EPA, it's the German DFG. If you have to work over in Europe, that's usually the most conservative one in Europe. And then it's also the TLV, and we just put them right next to each other so that you can flip through one book and see all of them. MSHA is not in there. I think the most convenient way to get the MSHA ones is actually still just looking at it online in the table format, right?
Well, you can't even find it online. I mean, that's all copyrighted. So supposedly you can go to an MSHA office and look at one. But other than that, it's just kind of like, this is pretty ridiculous. I mean, they're so far back. I mean, even their silica requirements are, just really archaic. But yeah, it's interesting. But yeah, that other document too, that's kind of a backup if you ever have to do things where you need to compare the different exposure limits. One thing I would really like, if you could mention this to management, if you could put in the Cal OSHA PELs.
Yeah.
Because the annotated PELs that OSHA published that basically said our current PELs are not protective of worker health, they reference 3 alternatives, and those 3 alternatives are the NIOSH REL, the ACGIH TLV, and the Cal OSHA PELs, which do keep up very closely to the current TLVs.
Yeah. Yep. And actually, they sometimes beat NIOSH too, right? They've kept up the pace, and NIOSH has kind of tapered off. Yeah. So I'm the management. So, so like I said, we're changing the format this year. So anybody who gets it, let me know. But that is a really good, that's a good comment. The Cal OSHA ones are probably more useful than the federal OSHA Pell by this point, right?
Well, thanks again, Philip. Thanks everyone for joining us today. As a reminder, we have the post-meeting evaluation survey in the chat box. You'll also receive an email with the information to claim CEUs. So make sure you fill that out. Happy Thanksgiving, everybody. Hope you have a nice and safe time with your families. And we'll see you back here in December.
Happy Thanksgiving, everybody.
Thank you.